Hi there. In this video, we will discuss the topic of context transition. It's a very fundamental concept, so I'll try to do my best to visualize things and to explain the concept to speed up the learning process. Before we get there, we'll also touch upon row context, iterators, filter context, dimensions, and star schemes, and they all are interrelated. So without further ado, we'll just get started with the row context. We'll just start by taking a look at this great article by the experts. And yeah, they quite nicely describe that newbies, they start writing DAX code, creating simple calculated columns. And this is an experience that's very similar to Excel because you can directly reference columns, add functions, and do some math. But as soon as you enter the world of measures, things suddenly change. And that has a lot to do because then you really need access to filter context. But we'll get there a bit later. But whenever you work with a calculated column, it's more easy because that required row context is automatically created. And a row context is more or less the current row in a table. Well, you might think, well, I'll just create everything in a calculated column. But as this article also nicely describes, is that you only use calculated columns whenever you're not able to implement it in Power Query. And in many cases, for those remaining calculations, you'd rather want to use a measure to make them more dynamic. So basically, it's more or less working either in Power Query or in measures. So you really need to get a good understanding of filter context, row context, and context transition. So I recommend reading the whole article, but I'll just highlight a few things and hopefully clarify those for you. Like this part. So very important. A row context is created by an iterator, and an iterator does what its name implies. It iterates. It scans a table row by row, and it computes an expression during the iteration, row by row. So I'll just try to visualize this a little bit in Excel. So imagine we have a week table, which is a dimension table, but we'll get there later. And it has one column, week number. Well, an iteration visually looks like this. So it's basically looping over the values and then having a pointer at a certain iteration value. And from that position, you can perform a calculation. Um, and we'll visualize that a little bit more later on. So we already moved over here. And now let's look into filter context. And let's look at this part of this video to listen how the confusion often arises.
Before we move further, I want to explain you one mistake that most newbies do at the beginning. They confuse the row context and the filter context because they think in terms of matrix. Now, if you focus on a row of the matrix, like this one, Contoso, that looks like a row. And you might tend to think that we do have a row context because we are in a row of the matrix. Unfortunately, that is wrong. A row of a matrix is not a row context. A row of a matrix defines a filter context. If you think about the number of rows that are being aggregated here, there are actually a lot, not only one row. There is one value for Contoso, but a lot.
Yeah, we'll just pause here. Um, so when you listen to this, I think it sounds recognizable that in a matrix, you're usually aggregating numbers, and it will be the sum of a bunch of values and the scope of these values. So the values that are considered or included in this calculation are determined by a filter, and that filter is set by the column value over here and the row value over here. And then by filtering the detailed data, usually in a fact table, we set the scope. We scope the data to be included in the aggregation, usually a sum, but also could be an average or so.
Lot of transactions that all happens under the products that exist in Contoso. It's not one row of a table, it's a selection of one value for a column that defines a set of rows that is being filtered by the filter context.
Yeah, so I think he mentions it here again, that it's basically setting the filter criteria for the data to be included in the aggregation. And I think we can visualize that even a bit more. So a matrix is two-dimensional. Yeah? So on the x-axis over here we have customer, and on the y-axis over here we have brand. And we might mistake this to be a row of a table, but it's basically a two-dimensional view on top of our detailed data. And because, by definition, it doesn't necessarily have to be a single value. It could be multiple values that we can see through this filter context, because the value d and x are determining a filter context, and then we aggregate this. So let's see, in this case, if we add a third dimension, then being which we can call week, then we see that the total of 5 here is composed of the values 2 to 1, which are the values split by week. And this allows us to get a multi-dimensional view on our data. And it's exactly this perspective on your data that I think is helpful when you look at the data modeling that's recommended, because we often would like our data model to be modeled as a star schema, and a star schema has a dimension tables, and I think you can quite literally view these as dimensions. And what's a dimension? That's the length, width, height, or time, perhaps. But basically, they allow you a perspective on your data, and that perspective determines what you can see. And we'll build on this a bit further. Also here in this article on Wikipedia describing a data warehouse, you also see that dimensions are categorical coordinates in a multidimensional cube. The fact is a value corresponding to the coordinates. And I think this is almost like the language framework, the context in which you can view your data. And I'll try to visualize this a little bit more. So we went over the dimensions and the role they play in a star schema, and I'll build on this a bit further. So let's clear this and take a different perspective on our data, which in our case, with a three-dimensional data set, we have our facts in the center in 3 dimensions. And that's quite convenient because we can then display it on a x-axis, a y-axis, and a z-axis. So let's look at it like this. And again, view what an iterator does. So the articles very often show you how to iterate the fact table, but I think it's more common to actually iterate over a dimension table. So let's do this in Excel, in Power BI. What we can do here is with this formula, we're iterating over the table week, and we've seen this over here. The iteration is looping over those values. So that's what's done over here. We're looping over those values, and then we access the column week number and that value is retrieved and then will be included in the summation operation. So 1 and 2 and 3 summed up adds to 6. So this formula works like this, and it works within a row context. And when we visualize it like this, we can, let's see, view it more like this. So we ignore the rest of the model, then we have our dimension values, and then we can iterate over those. And this is how this looks. Now, let's do some iterations, but now go beyond the row context, because instead of working with the same table as we're iterating, we will access the fact table. So we'll go to data and value. We'll try to sum this up. And we get an error message stating that a single value cannot be determined. And that makes sense because for 1 week we have multiple values. So we need to aggregate. In this case, we could say let's sum it. And now something strange happens. We would expect a value of 42, yet we get the value of 126. And when we use concatenate x, we can start to print the values that were used. And now you see that it has used 42 for each week number. And yeah, this is something that I think you can visualize like this. So we have our cube, and when we iterate weeks, we see that with each iteration, the part in green is what the calculation sees. So let's try this again. Let's do this again. So with each iteration in green is what's available to it. So it views the entire cube with each iteration. So with each iteration, the filter context is not set properly because it still sees the entire cube. And what we'd like to see is that it sees the data belonging to the week, so that it slices the cube properly. And for this, we need to add calculate, and then with calculate, context transition occurs. Whereby the row context is used to set a new filter context. So now we already see that it's using the values 16, 13, and 13. Change this to SumX. And then we get this value of 42. And let's visualize this. So let's clear. And now we see with each iteration it's slicing the cube by applying a filter context. And that filter context is set by the row context. Yeah, and this concludes this video. And in future videos, you'll see this type of 3D visualization more and more because it will be quite helpful when we want to visualize nested iterators, for example, or do more complex logic. Whenever we're able to visualize the data, it becomes a little bit more easy to comprehend, hopefully. So just let me know what you think, and I'll see if I can work with your feedback. Thanks a lot. Bye bye.